All right, we're now going to do something called a backward scan. Backward scan. If you've got a red pen, I want you to do this in a red pen. The reason why we do a backward scan is to find something called the latest start time. The latest start time. So we'll put it in brackets. This is the latest start time. And just to give you a bit of a definition here, which we'll see later on, the latest start time the latest start time is the time an activity can start if the whole project is still completed on time. Now, the way that we find our latest start time is we begin at the end. And remember, since the last video when we did the forward scan, we found that this whole project takes a minimum completion time of 318 seconds. So now with our backward scan, what we're going to do is grab our red pen and start at the end. And we're going to say, all right, 318 minus 3 is going to give me 315. So in a red pen, I put 315 here. And what this is telling me is that, and I'm going to write this in here, but you don't write this in, otherwise your page will be a mess. What this here is telling me is that the latest start time for F is 315 seconds, meaning if you want to finish this on time, if you want to complete this project on time, you need to make sure that the latest time you start activity F is 315 seconds, because you know it takes 3 seconds to do activity F. And if you want to end at 318, you better make sure that you start activity F at 315. Let's imagine for a second that you started activity F at 316. Well, if you started at 316 and activity F takes 3 seconds, then you're going to finish at 319 and you haven't finished on time. So the latest start time tells me the time at which the latest you can start at in order to finish on time. All right. The way that you find your latest start time for activity E is you take this latest start time and you minus the length of activity E. So it's going to be 315 minus 5 is going to be 310. So I'll put that there. And again, what this is telling me is the latest start time you can start activity E is 310. Now, this is where it gets interesting, because now do you see that I have two edges coming from this vertex here? I have this edge and I have this edge. So what I need to do is I need to say, all right, take this latest start time and subtract 300 seconds from it. So 310 minus 300 is 10 seconds. So that means the latest start time that I can start activity B is 10 seconds. And then we do the same thing. So 310 minus 5 is going to be 310 minus 5 will be 305. Now, this is where it gets interesting. This is telling me that the latest start time for activity D is 305, meaning if you want to get done at 310, you want to finish activity D by 310, you can start activity D at 305 and still be done at that time right there. Now, the reason why this works is because you know that this entire pathway here takes 310 seconds, right? So let's really take a step back. You know that this entire pathway takes 310 seconds. And you know that this pathway takes 10 seconds because 5 plus 5 is 10. So, in other words, if you finish this as soon as possible, if you go quickly through it and you go 5, 5 is 10, you're going to end up waiting 300 seconds in order for this pathway to be done. So instead of waiting 300 seconds at the end here, why not delay activity D? Why not, after you've finished activity C, which takes 5 seconds, kind of wait 300 seconds until you start activity D, and then you can start activity D at 305, and then that takes an extra 5 seconds, and then you're done at 310. Now, this introduces another idea, and we'll come up here, and this is the idea of float time. So we'll come up here and let's talk about float time. So we'll write float time. The way that you find float time is you take your latest starting time and you subtract it from your earliest starting time. And again, all of these notes are in our booklet later on, but I think it's really helpful to write it in here. So the latest start time minus the earliest start time is going to give us something called the float time. So for instance, for activity D here, for activity D, what we can do is we can say, all right, my latest start time for activity D is 3:05, and my earliest start time, so wait, subtract, and my earliest start time for activity D is 5 seconds, 5 seconds. So that means my float time here is going to be 300 seconds. So again, what is that telling me? So 300 seconds is the float time. What that is telling me is that activity D can start anywhere between 5 seconds and 305 seconds. So activity D has a float time of 300 seconds. And what this means is that, we can start anywhere between 5 and 305 seconds for activity D without impacting the overall completion time for the project. So for example, we could, after we've completed activity C, delay starting activity D for up to 300 seconds, and we're still going to make sure that we hit this vertex at 310 seconds. That's the idea of the float time. Hopefully that makes sense. Again, we're going to talk more about this a lot, so don't be too freaked out if you're looking at me at the moment and thinking, what on earth does that mean? We're going to go through lots of this here, but if you can just get a bit of an intuitive understanding of this at the time being, it's really helpful. That we have a float time for activity D of 300 seconds. All right, we now need to continue with our backward scanning here. So let's zoom in here. To figure out our LST, our latest start time for activity C, we take our latest start time for activity D and subtract 5. So 305 minus 5 is 300 seconds. And again, hopefully this makes sense. Hopefully it makes sense that we could start activity C at the latest time of 300 seconds. Because remember, and again, don't write this part in, I'm just going to do a bit of light scribbling here. We know that this here, all of this, takes 310 seconds. So why not wait until, 300 seconds? Why not wait 300 seconds until you start putting in your coffee and milk? Because you know that your coffee and milk only takes 10 seconds, right? So if you start at 300 seconds and then you take 10 seconds to put in your coffee and milk, you're going to hit that 310 seconds here. You've got slack here. You can delay things here because this is taking so long. All right, hopefully that makes sense. We continue on. We now say, all right, we need to do our latest start time for activity A. So we take our latest start time for activity B, we subtract this, 10 minus 10 is 0. And just like that, we have finished our backward scanning. They're all our red numbers, and we've also had a really great discussion on the float time as well. Hopefully all of this has made sense, and we'll continue on now.